Hello everyone, this is Jay from BTYT Tech Library. Today we are going to make classic favorite game with just a few lines of code. Excalibur is a free open source 2D game engine written in TypeScript for making 2D games for the web. It says it takes the burden off your shoulders with its all-in-one engine code, cross-platform support, and additional features, empowering you to focus on what matters most, your game. Sounds intriguing? To me, aside from its nice philosophy for the game engine, since it's based on TypeScript, you can super easily adapt your creation to the web, which was quite impressive. We'll see that in a minute. Breakout is a game where you break bricks at the top of the screen using a ball that bounces off a player pedal. The ultimate goal is to clear every brick from the playing field while avoiding having the ball roll off the bottom. It's not a AAA game, but it's a decent classic that Google demined the DeepQ networks trained on. We are going to learn by doing approach. Through implementing a simple game together, we will get familiar with how to build a game using the object-oriented TypeScript first API, similar to Unity and Godot. Let's code along. Let's take the easiest way. With Node installed, run the following on the command line. In the generated project, go to the main.ts file in the source folder. Delete all the pre-generated codes and start from scratch. We are going to jumpstart the implementation and later port this source to the browser as a JavaScript module. Excalibur employs a theatrical approach to structuring gameplay, dividing it into distinct roles such as actors that can move freely within the current scene, which is contained within the engine component. Create the instance of the engine, and let's set a game size to 800 pixels wide by 600 pixels tall. If no dimensions are specified, the game will be rendered full screen. To start the game, we need to call engine start function. When we run the program, we can see the blue screen of goodness. Good. Now let's create a pedal. We need to introduce an actor to our scene. Create an actor by giving its arguments coordinates, size, and color. Then set the collision type to pedal body. Without this, the pedal actor is just a shape or a drawing, as it cannot interact with other actors. Lastly, let's not forget to bring our actors to the stage. Movement and interaction make this game really come alive. Let's add the event listener and make the pedal follow the mouse around in the X direction. Next, let's create our wrecking ball. Create the ball, which is also an actor, and start the sub after a second by giving the velocity through the motion component's val property and the browser's setTimeout method. Of course, for interactions, let's set the collision type to passive, which means only raise collision events but are not influenced or moved by other actors and do not influence or move other actors. Lastly, let's not forget to bring our actors to the stage. The ball's initial velocity has been set to 100 pixels per second, causing it to move downward and to the right. In the next step, we'll implement a boundary check that will allow the ball to bounce off the side of the screen. There are three primary entry points into the actor's update loop: on pre-update, update, and on post-update. These methods enable actors to execute core logic, with the pre and post method hooks providing flexibility for conditional execution. Okay, let's create a bricks to break. We are going to set some constants for 3x5 grids for bricks. And its colors. Then create its brick actors via loops. After completing the collision settings for interaction, lastly, let's not forget to bring our actors to the stage. When a ball collides with bricks, our goal is to remove the bricks from the scene. We achieve this using the collision start handler, which triggers upon initial object contact. For more delicate tracking, such as capturing every resolution update, we utilize the post-collision handler. When a collision happens in the game, this code makes body A turn around to avoid hitting body B. A variable called intersections tells body A which way to move. Think of ev.content.mtv as a tiny arrow that points in the direction body A should move. The normalize function makes this arrow shorter so it's just 1 unit long. Then, the negate function flips the arrow around so it's pointing in the opposite direction. Finally, let's set the game over conditions. If the ball passes the pedal and goes off the screen, game over. Good. It's time to check where Excalibur game engine really shines. First, let's create a really simple HTML file. Just open the file in the browser. Port our game as JavaScript module. Import the Excalibur game engine by CDN. Quick fix to on type declaration between TypeScript and JavaScript differences. Then refresh the browser. Say goodbye to a boring meeting and game starts. How about that? Excalibur's free and versatile game engine has a built-in ECS data-oriented framework like Unity does. Physics simulations, tilemap plugins, and a DevTool browser extension. Hope they update Dino 2 guide and support. Although it is still waiting for the official 1.0 release, I think it is worth keeping an eye on as the next TypeScript game engine. Next time, let's create a famous side-scrolling mobile game together, and learn how to use images, graphics, and sound in the Excalibur game engine.